Hey everyone, welcome back. Ready to go deep on something kind of sneaky. We're talking all about hydrogen today.
Yeah, it's one of those things you see on the periodic table but don't think much about.
Exactly, just that little box, right? But it's got so much going on. Like, did you know most of the universe is made of this stuff?
It's wild. About 75% of all the normal matter out there.
That's just mind-blowing.
Yeah.
But here on Earth, it's a little different.
Oh, yeah. Hydrogen gets complicated down here.
It's like it can't decide if it's good or bad.
Truly. I mean, no water, no life, no anything organic without it. But
But then it messes with our stuff too,
big time, weakening metals, causing cracks, all sorts of failures.
which is a big problem for anyone trying to use hydrogen.
Exactly, like in energy or transportation.
Okay, so double-edged sword it is. Let's start with the good side. We know it's abundant and makes up tons of things. How's that even work?
Well, hydrogen's a sharer. At the atomic level, I mean. It
Yeah.
forms these bonds, covalent bonds with other elements.
Especially with nonmetals, right?
Yeah, those are its favorites. And those bonds are strong, super stable. That's how we get all these complex molecules in the first place.
So hydrogen is like the glue holding everything together.
Pretty much. Without those connections, we wouldn't have water, air, even the proteins in our bodies.
That's heavy stuff. But there's that other bond too,
You
right?
got it, hydrogen bonds.
Oh, yeah. From way back in chemistry class. Weren't those kind of weak, though?
They're weaker than covalent bonds, that's true.
Sure.
But they're still super important.
Like, how important are we talking?
They're the reason water acts so weird, in a good way. Like why it takes forever to boil.
Or how it dissolves, like, everything.
Yep, even ice floating, that's hydrogen bonds at work.
Okay, so weaker doesn't mean useless. But how do they actually work? Down at the tiny level.
Picture a water molecule. You've got oxygen in the middle, two hydrogens attached.
Okay, I'm picturing it.
Now, oxygen's a bit of an electron hog, pulls them towards itself more strongly.
So that creates an imbalance.
Exactly. Tiny plus and minus charges pop up. Oxygen's a little negative, hydrogen's a little positive.
And we all know what happens with opposites.
They attract. So that slightly positive hydrogen on one water molecule, it's drawn to the negative oxygen on another one nearby.
Ooh, hydrogen bond.
Exactly. And they form this whole network, holding the water molecules together in a really specific way.
That's pretty wild, happening all the time in every sip of water.
Yeah.
Okay, but bigger picture now, how do we actually get pure hydrogen? It's everywhere in the universe, but down here.
Most hydrogen today, sadly, comes from fossil fuels.
Ugh, not what I wanted to hear.
I know, right? One common way is using natural gas. It's called steam reforming. Methane reacts with superheated steam, and you get hydrogen gas along with carbon monoxide.
So pulling hydrogen out of hydrocarbons, not exactly eco-friendly.
Yeah, not the best. That's why there's so much research into cleaner ways.
There better be. What are some of the options?
One that's really promising is electrolysis. Basically, you zap water with electricity
Then it splits apart.
into hydrogen and oxygen. And if that electricity is from renewables like solar or wind,
Then you get what they call green hydrogen. That's got to be the goal.
absolutely. And nature has some tricks up its sleeve too, believe it or not.
Oh, do tell.
Some bacteria can actually make hydrogen gas, part of their normal processes. They use special enzymes called hydrogenases.
Hold on, bacteria like tiny hydrogen factories.
In a way, yeah. And that's not all. There's this geological process called serpentinization.
Seeing that 5 times fast.
Right. Happens deep underground. Water reacts with certain rocks.
Sounds complicated.
It is, but the cool part, releases hydrogen gas as a byproduct.
So even rocks are making hydrogen.
Yeah.
And nature's pretty awesome. All right, so we've got ways to get pure hydrogen. But storing, it's got to be tricky, right? I imagine it's not like filling up a tank at the gas station.
You're right. Storing hydrogen safely and effectively, that's one of the big hurdles.
Like, what makes it
Sure.
so hard?
Well, for starters, it's way lighter than gasoline and doesn't pack as much energy into the same space. So you need massive tanks to hold the same amount of energy.
Space is a big issue then. What are people doing about it?
One way is compressing the hydrogen gas under high pressure.
Cram more in, basically.
Yeah, but then you need special tanks that can handle all that pressure.
Makes sense. What about turning it into a liquid, like we do with natural gas?
They do that too, but it gets crazy cold.
How cold are we talking?
Like negative 253 degrees Celsius. That takes a ton of energy and serious insulation to keep it from boiling off.
Wow, that's insanely cold. So storing pure hydrogen, either way, has its downsides. Anything else people are trying?
Researchers are looking at materials that can absorb and release hydrogen, like sponges, kinda.
Hydrogen sponges, that's a new one. How does that even work?
There are a few types, but one example is metal hydrides.
Metal hydrides.
Yeah, certain metals can actually absorb hydrogen atoms right into their structure, forms this solid material. And the cool part is, you can heat it up to release the hydrogen gas when you need it.
So it's like trapping the hydrogen, then letting it out on demand.
Exactly. And there are other types too. Some scientists are looking at special chemical compounds that can do the same thing.
Sounds like a whole new world of storage options. Okay, but big picture again. Why are we even so interested in hydrogen as a fuel in the first place? What makes it so special?
Environmentally speaking, it's clean. When hydrogen burns, you get only water vapor.
No emissions. That's got to be a huge plus these days.
Huge. And it's not a one-trick pony either. Fuel cells for electricity, burn it directly in engines, even make other fuels and chemicals from it.
So it's not just about swapping out gasoline, it's a whole system change. But let's be real. What are the biggest hurdles?
Well, cost is the big one right now. Most ways of making and storing hydrogen are more expensive than just using fossil fuels.
And we talked about how tricky and expensive storing it can be.
Right, so it's a chicken and egg situation. We need cheaper hydrogen for people to use it, but we need people using it to make it cheaper.
Classic catch-22. What else?
The whole infrastructure thing. We'd need pipelines, storage, refueling stations, the whole shebang.
That's a massive project,
Yeah.
but the potential benefits are huge if we can crack this hydrogen puzzle.
It could be a game changer. And there's definitely momentum building, governments, industries, research. Everyone's getting in on it.
I'm rooting for Team Hydrogen.
Yeah.
It's clean, versatile, abundant. It's got it all. But I'm also curious about real-world stuff. We know it can be used as a fuel, but where is it actually happening? And what about more futuristic applications? What's on the horizon?
Great questions. And that's exactly what we'll dive into next time. We'll look at how hydrogen's already changing things in transportation, power generation, even food. And we'll peek into the future to see how it could revolutionize everything from airplanes to building materials.
Sounds good to me. I feel like we're just scratching the surface here. So stick around. Our hydrogen adventure continues next time.
Welcome back to our hydrogen deep dive.
I'm ready for more. Last time we were talking about how hydrogen is kind of a two-faced friend and all about those bonds, covalent in hydrogen, and of course the whole production and storage headache. But now I really want to know, how's this stuff actually being used out there?
All right, well, one of the most talked about uses is in transportation. As a fuel, I mean.
The hydrogen cars? I keep hearing about those, but honestly, not sure I get how they actually work. Are they like electric cars?
They are similar in that they're both zero emission at the tailpipe, but the way they store and use energy is different. Electric cars rely on batteries, while hydrogen cars use fuel cells.
Fuel cells, right. Those rang a bell. But remind me, what are they again?
Think of it like a battery that never runs out. As long as you keep feeding it hydrogen, that is, that's a fuel cell, it converts the chemical energy in hydrogen directly into electricity, and the only byproduct is water.
So is a hydrogen car basically an electric car powered by a fuel cell instead of a battery?
You could say that. The fuel cell makes the electricity from hydrogen, and that powers the electric motor. Makes them super quiet and efficient, just like electric cars.
Okay, so why aren't we all driving hydrogen cars then?
Well, there are a few roadblocks, like fuel cells themselves are still pretty expensive to produce, which makes hydrogen cars less affordable than gasoline or even electric cars for now.
Right, cost is always a factor. What about that infrastructure problem we talked about before? Are there even places to, fill up a hydrogen car?
That's another challenge. Right now, the network of hydrogen refueling stations is pretty small compared to gas stations for gasoline-powered cars. So people might be hesitant to buy a hydrogen car if they're worried about running out of fuel on a road trip.
It's like we need more cars to justify more stations, but people won't buy the cars until there are more stations.
Yeah, it's a tough cycle to break. But things are moving in the right direction, slowly but surely. A lot of the big car companies are investing in hydrogen technology, and governments are trying to support hydrogen infrastructure.
Okay, so maybe hydrogen cars aren't taking over the world just yet, but it sounds like they have potential down the line. What about other types of transportation?
Well, hydrogen is being tested as a fuel for all kinds of vehicles, actually. Trucks, buses, trains, even ships.
Because it's so energy dense.
Exactly. It's a good option for those bigger, heavier vehicles that need to travel long distances.
And if it takes off, that could really help clean up the transportation sector. Speaking of cleaning things up, you mentioned power generation before, right?
Yep. Hydrogen can be used in fuel cells to generate electricity, not just for cars, but for buildings and even whole communities.
So these are like mini power plants that run on hydrogen.
You got it. Fuel cell power plants. They're incredibly clean and efficient with no harmful emissions, and they're already a reality. There are actually a few operating around the world, and many more are in the works.
So they're not just some futuristic idea. Where do these fuel cell power plants work best?
They're really good for providing backup power or powering remote areas that are hard to connect to the main grid.
That makes sense. It sounds like fuel cells are pretty versatile then. What about using hydrogen directly as a fuel in power plants rather than in fuel cells? Is that something people are looking at?
They are. Some power plants are actually experimenting with burning hydrogen in gas turbines to generate electricity. It's kind of similar to how they burn natural gas now, but with zero carbon emissions.
So potentially hydrogen could replace natural gas in power plants. That would be huge.
It would be a big step towards cleaner energy for sure. But there are some technical challenges, like they need to modify the existing gas turbines to handle hydrogen properly.
It's never as easy as we want it to be, is it?
Mhm.
I also wanted to go back to something you mentioned before, hydrogen as a building block for making other stuff, like fuels and chemicals.
Oh, yeah. Hydrogen is super important in the chemical industry, like for making ammonia, which is essential for fertilizers, and methanol, which can be used as a fuel or as a starting material for other chemicals.
So it's not just a fuel itself, it's an ingredient for making other important things.
Exactly. And that's not even all of it. It's used in tons of industrial processes, from refining petroleum to making steel.
Wow, okay, I get it. Hydrogen is basically everywhere. I'm honestly kind of blown away by how versatile it is. But let's zoom out for a sec. What's next for hydrogen? Are there any really futuristic, maybe even sci-fi applications on the horizon?
Now we're talking. That's what we'll be exploring in the final part of our deep dive. We'll look at how hydrogen could revolutionize things like aviation and even building materials. Stay tuned.
Okay, I'm ready to blast off into this hydrogen-powered future. We've talked about hydrogen's chemistry, how it's used now in transportation and energy, even its role in food. But now, let's really go big. What are some of those futuristic sci-fi kind of uses for hydrogen that could really change the world?
Get ready to fly high because we're starting with aviation. Picture this airplane's cruising through the sky, leaving nothing but water vapor trails. That's the dream of hydrogen-powered flight.
Zero-emission airplanes, that would be amazing. But is it even possible? Planes are huge, they need so much energy. Can hydrogen really handle that?
It's a big challenge for sure, but not impossible. Scientists are working on fuel cells powerful enough for planes, but light enough so they don't weigh everything down. And remember, hydrogen packs a lot of energy for its weight, which is a big help when you're fighting gravity.
So it's like a weightlifting competition. And hydrogen is showing off its muscles. Are there any hydrogen planes actually flying yet?
There are. Some companies are testing out hydrogen electric planes, and smaller aircraft are already using hydrogen fuel cells for short flights. It's still early days, but things are moving.
I can't wait for the day when hydrogen planes are normal at airports. It would be a huge win for sustainable travel. Okay, but why stop at Earth? What about space? Could hydrogen play a role out there too?
Definitely. Hydrogen's already a key player in space travel as rocket fuel, and scientists are looking into it as an energy source for Moon and Mars bases.
Rocket fuel. Of course. It makes total sense given how powerful it is and that it produces water, which is super valuable in space.
Exactly. And speaking of valuable resources, let's talk about another futuristic use, building sustainable materials with hydrogen.
Now we're talking. Tell me more.
Imagine buildings made from materials that are strong and durable, but also carbon neutral, or even carbon negative. That's the goal with hydrogen-based materials.
Carbon negative buildings. That sounds straight out of a movie. How does that even work?
It all comes down to how the materials are made. Researchers are finding ways to use hydrogen to actually capture carbon dioxide from the air and turn it into building materials, like plastics and concrete.
Wait, so you're saying we could turn pollution into construction materials? That's incredible.
It really is. This approach could not only reduce emissions, but create a circular economy where carbon is constantly reused.
This is giving me so much hope for the future. It sounds like hydrogen has the potential to make a real difference in creating a sustainable world, from transportation to energy, even to the materials we build with.
I agree. Hydrogen's versatility and its potential to solve some of humanity's biggest problems make it super exciting to work with.
This deep dive has been amazing. I've learned so much about hydrogen, and I'm genuinely excited about what it could do for the future. But before we wrap up, what's your biggest takeaway? What's the one thing you want our listeners to remember about hydrogen?
That's a great question. I think the most important thing is this hydrogen is more than just an element on the periodic table. It's a powerful force for change, a chance to reshape our world for the better. It's abundant, it's versatile, it's clean, everything we need for a sustainable future. And even though there are challenges, the progress we're making is amazing and the possibilities are endless.
Well said. I think that's the perfect note to end on. Thanks to everyone out there for joining us on this journey into the world of hydrogen. We've explored its past, its present, and its potential to create a brighter future for all of us. And keep exploring. There's a whole universe of knowledge out there waiting to be discovered. Keep learning, and let's unlock the amazing potential of hydrogen together.